Hello, everyone. Once again, I welcome you here at the opening of our Malahit School. This year, we greet our great speakers, thanks to whom the school is now open and thrives like never before. I want to introduce you Ivana Ямщикова, who is here to tell you about his course. Yes. He's here to tell you some information about his course, which is called Open Questions in Natural Language Generation. A few words about Ivan himself. He is a postdoc at Max Planck Institute for Mathematics at Leipzig. He joined us here not for the first time and is willing to share his thoughts and knowledge with you. In his talk, he will discuss several bottlenecks of current natural language generation methods that use end-to-end statistical learning. We will start with the general formulation of stylized language generation, introduce the empiric definition of literary style, and make a deep dive into the decomposition of stylistic and semantic information in the context of style transfer. It all sounds quite difficult, but I'm sure Ivan will manage to make it as simple as possible. The talk itself is an overview of several results on poetry generation, style transfer, and semantic representation. And before we start, I would like to remind you that you're welcome to write all of your questions in chat. Because we're still announcing this contest. If you want to win this brand t-shirt with our logo, please welcome to write your questions and we will select the best one and present this gift to you. The winners will be announced in our Telegram channel. The link we will leave below in the chat as well. And now, if you're ready, Ivan, you're welcome. The floor is yours.
Sure. Thanks a lot, Vasilisa. And thanks everybody for joining us today. I'm currently in Germany, so it's rather early morning, but not too early. I'm sure if you're somewhere in a different part of the world, probably you are in different time zones. So thanks for joining. Thank you very much for Ural Federal University for running this event, for organizing it. A year ago, when we first came up with the idea to organize it, it was great to be in Ural University, to invite some people to join. And it's also really nice that some people that we managed to attract last year stick for this year. And some of you will enroll in the multiple online learning course that we try to develop as a part of the school. And I would like to say in advance, thank you very much for beta testing it. It was a very novel and very interesting experience for me. So I hope you'll enjoy learning what we prepared for you, but also give us feedback, because it's my first experience of designing something like that. We had to adjust due to pandemic and couldn't meet personally in Ekaterinburg. Unfortunately, maybe next year with Russian vaccines available for the whole world, we would be, but so far we do it remotely. So thanks again for joining. And I'll briefly cover some of the research projects that we did with my colleagues in Max Planck Institute and with my colleagues in Yandex, and also with my colleagues in Ural Federal University. There are several papers that we have already published. There are some results that are currently under review, and we hope to get them published in the nearest future. So I'll try to give you a general overview of how I think we should approach natural language generation. And I think style transfer, which is the problem when you need to reformulate a given sentence, preserving some aspects of its semantic content, but changing how it is versed, is actually a very nice task, a very nice angle at which you can look at natural language processing in general. And this is why I'm trying to center this talk around style transfer. But in the end of the talk, we'll discuss more general questions that I think are crucial for deeper understanding of natural language processing. And ultimately, I believe understanding the language would massively advance us in our understanding of knowledge itself, because we tend to think in language, and cognition is to a large extent a verbal endeavor. So I think that natural language processing is vital as a research area, and not only within the framework of machine learning, and computer linguistics, but also generally as an area that could advance our understanding of intelligence and cognition. Okay, let's go on, and at first let's discuss the difference between style and semantics, and in particular, whenever you face the question of like, is there a fundamental difference between what is said and how it is said, you intuitively always know the answer, right? You always know that you can say the same thing, but in very, very different ways. And we as humans, we are strange beings, and sometimes form matters way more than content. And also, you know that form quite often is connected with some emotional aspects of our being. For example, you can talk to a dog, and dog doesn't understand the semantics of what you say. Dogs probably don't understand meaning of what you say, but depending on your tone, the dog would either think that you are mad at it, or maybe think that you're actually happy. You can say, if you're sounding kind and you say, "Oh, you stupid boy, what have you done, you stupid idiot?" The dog would probably think that you're saying something good to her. And then if you say something like, "You good dog, very good dog," the dog would probably get worried and irritated. So the notion of difference between style and semantics is actually far deeper in our neural biology than on the level of language. Even non-primate vertebrates actually know the difference between style and semantics. So it's clearly something that you should be able to decompose. However, when you start to work with actual language and you start going to linguists, and at first we tried to approach this thing with open heart. We came to people who study philology, who study literature, and we were saying, "Hey guys, we are awkward, we are mathematicians, we don't know anything about your literature things, but could you tell us how we define stylistic? Like, there are marvelous authors. It's clear when you read Oscar Wilde that what you read is very different than what you read when you read Ernest Hemingway, right? It's clearly written in a different way. So could you tell us how we can measure it? What are your insights? What are the numbers? What should we look at?" And we were doing that for some time, and people who do like linguistics and philology and literary theory, they looked at us like blank stared and then said, we don't measure these things. We don't, you feel them. You're supposed to have an aesthetic feeling about how certain things are written. And, you know, mathematicians are a bit short on feelings. So we thought, okay, we cannot deal with this measure of quantifiability. So instead of trying to define it rigorously, we thought, what if we can learn style end to end? And basically, this was the endeavor of this paper that we wrote in 2018 with my co-author, Alexei Tikhonov, who's based in Yandex Berlin. And what we tried to do was basically as follows. We gathered as much data as we could. We gathered as many poems as we could, and we did this in 2 languages. We did this in English and we did this in Russian. And for both languages, we gathered the data set that was, I think for Russian, it was basically every Russian poetry that we could find, starting from Alexander Pushkin, finishing with modern rappers. And for English poetry, we gathered as much as we could as well, but probably the data set for English was a bit smaller than for Russian, as far as I remember. But the point was that we gathered all the data and we accompanied the data of every particular poem with an ID of an author who wrote this poem. And then we were training the generative system. We were training the autoencoder system. You can look into the paper for more details. You can scan the QR code and go into the web page with the paper details. Probably we can also put the descriptions and the links to the papers in the description of the video after the talk is over. But the point is that we trained an autoencoder on the whole data set of texts. And then we conditioned it on the particular author, and we tried to validate how close the model gets to the text of the author. And the first fact that was actually kind of obvious, but not trivial back then when we did it, was that apparently it is much better to have as much data as you can and then condition it on a particular author than just to train network on one particular author data set. Because before, there were some attempts to do stylized text generation. There were a lot of people who were doing Shakespeareization, for example. Shakespeare was very prolific. He wrote a lot of things. So you had enough data to train some form of recurrent neural network, for example, on Shakespeare, and then you generate some text with it, and it sounds a lot like Shakespearean text. So there were attempts to do it for the single author, but the first statement that's clearly obvious, but back then it was not, is that when you have more authors in your data set, and when you condition your model on a particular author in the generation phase, the overall quality of your model improves, but also apparently stylization, whichever metric you choose to measure how close your style is to the style of the author. We were in particular using just BLEU, comparing with the human written baselines, trying to continue the sentence that author started and seeing how the model finishes the sentence and how the author finishes the sentence. So it turns out that it's actually extremely beneficial if you have bigger data sets and you condition the information about the author and you plug it into the model in some way. It turns out that it's very, very useful, and the models can learn stylistic representations end to end. Here's an example of a poem, for example, that we generated. Her beautiful eyes were bright. This day is a burden of tears, the darkness of the night, our dreams of hope and fears. This is an actual generated poem. Every line by line is generated by an artificial neural network, and then the rhyming is done heuristically. So these are random lines connected together through the rhythm and rhyme. But when you read it, it feels legit. It feels like that might be a poem. The best thing about it is that this particular one is the modal conditions to generate Edgar Allan Poe. And if you read the poetry of Edgar Allan Poe, this thing also sounds legit. This is something that Edgar Allan Poe could have written. And that was the whole point. We just gathered the data. We didn't tell the model any expert knowledge whatsoever, just as much data as we could, and information. This guy wrote that, this lady wrote this. That's it. And then we trained it end to end to reproduce some stylistic patterns that it could observe to the best extent of this of its capabilities. And we could see that apparently some relation, some connection, some stylistic features apparently could be extracted end to end without any injection of expert knowledge. And this was, of course, a very optimistic sign for us, because that meant that we can proceed with this idea that style and semantics are two different components. And then, okay, apparently you can learn style end to end. Moreover, we checked it on actual human respondents. We generated quatrains of our Euro poets, and then we sampled some random quatrains of actual poets, and we're asking humans to say who wrote this poem. And it turned out that when people recognized an author, so for example, we thought people could be able to recognize Lewis Carroll, but apparently people don't recognize actual Lewis Carroll. They have hard times guessing that this is a human who wrote it. Apparently, Carroll's style is not that clear for people, at least the ones who were in our poll. But when people understand that this is a particular author, people recognize Shakespeare, people recognize Bob Marley fairly well, then they quite often recognize stylized neuro Bob Marley or stylized neuro Shakespeare for actual author. They sometimes vote for the model, but sometimes they vote for the author. So it means that humans also see that the certain stylistic features are captured by the model within its generative output. Okay, so this was the first step, and this was made us optimistic. Of course, there are a lot of things you can improve from there, but the whole idea that style is something that you can actually extract out of your data without any expert preconceived knowledge is the first take that we should have here. And then once we know that this is true, we can discuss the problem of style transfer, which is a more applied problem. I'm sure, especially if you're not a native speaker of English, you had a problem of writing an email and hitting a right note, right? So you know what you want to say. For example, you got an email from your boss, and this is this type of like 10:30 email where the boss says that you should definitely send this report by 8 o'clock in the morning tomorrow. And you definitely want to say that you won't, that it's Sunday and probably you'll be a bit late on this one, and maybe somewhere around lunch you can send it, but not now for sure. It was not on your plan, not on your list, not on your schedule. So you have a notion of what you want to say, but also you have trouble saying it in a most, let's say, courteous way possible. You have trouble expressing your thoughts in a way that they come across in a clear, concise fashion, but also not too offensive, but also not too, insecure. You want to hit just the right note. And if you're a native speaker, it's hard. Wouldn't it be amazing if you could just write what you mean and then the model, and then you choose the correct style that you want to convey, and the model just alters your text in a way that's, friendly enough, professional enough, and also, polite enough, yet rather clear and, assertive in a sense, right? Wouldn't it be nice if you could just tick certain flags in your mail app and then send it away? So the idea of style transfer is exactly that, is the question whether you can take some input, save the semantic aspect of it, and tweak the stylistic part of it automatically in a way that you want. And there is actually a lot of work that's done in this area, and a lot of people try to solve this problem as a back translation problem. So they suggest to regard style transfer as a form of machine translation, right? How do we translate from French to English? We have text in French, we have text in English, it's in parallel, and then you have a model that basically learns how the patterns in one language correspond to the patterns in the other, and you hope that if your model is good enough and if your data is good enough, then you can be very, very precise. And if you ever tested modern machine learning translation models, you'll see that they are actually amazing. And I'm a bit upset that when I was younger, I put so much effort into learning foreign languages, because apparently machines can do it really, really well. And but there is another approach to this task, and the approach basically is motivated with the idea that if we talk within one particular language, there is a continuous amount of possible ways and combinations in which you want to play with the style, right? As this boss example, you want something to be polite yet assertive. You want something to be friendly yet formal, and so on and so on and so on. So there are a lot of particular smaller aspects, and it's not very clear what is the correct level of fragmentation of style that you want to convey. So you cannot actually prepare a parallel data set that's good enough, because the problem is actually very complex, and the complexity grows once you want to get even deeper and even more precise about how you stylistically express certain things. So instead of treating as a machine translation problem, what people suggest to do is to use some form of autoencoder and some latent space representation. So general idea of autoencoder is that you can have a network that encodes information in a vector, some vector space that basically hopefully captures the meaning. And then you have additional components of this vector space where you specifically, maybe manually even, encode certain stylistic aspects that you would like to change. Then you concatenate these two vectors, and this is your input for the generator model. So your generator model has the knowledge of your semantics that basically preserved and carried through, but also has additional stylistic component to it, and just unfold your text out of it. And there are a lot of research done in this area, and this particular paper that we wrote with some of my colleagues from Ural Federal University, this is our EMNLP paper. And what we did there is, first of all, we mapped all possible solutions in this area on the left plot. And then we came up with several improvements of the baseline that people from Carnegie Mellon proposed in 2017. I will not go into too much detail here. Again, you can look the paper up because we are running out of time, unfortunately. But we tested several architectures. And what we showed is, first of all, that these things, at least majority of them, are very noisy. And once you take this into consideration and you train this kind of system several times, then it's getting much harder to compare them in terms of their quality. The second thing that we showed is that majority of the metrics that people use currently to estimate how good the semantic is preserved and how good the style is preserved, they could be tricked in a rather naive and simple way. And unfortunately, so far, to reliably measure how good your system is, you have to have human written rewrites. So once you have humans who rewrote your text in the way you wanted them to do, you can test your system based on this latent space representation. But clearly, this is no good because it basically means that we have to have parallel texts. Maybe we don't need to have so many parallel texts as people who do try to approach this problem as machine translation problem, but we have to have parallel corpora. And this is probably suboptimal. But the key factor is, of course, the question on how we can measure semantics generally, how we can measure semantics without human baseline and clear overlap with the correct answer. And this is basically the next area that we try to approach. And this is the paper that's currently under review, but I hope we will get it through quite soon. And what we did is we measured 14 different semantic similarity measures for various texts. And this is, again, joint work with Slava Shibaev, one of PhD students in Ural Federal University. Thanks, Slava, for putting this great work into it. So we gathered the data on 14 different metrics, and we proposed new data set of paraphrases when we basically have the same text written in different ways, like several parallel translations of Bible, for example. Then we had style transfers, where we actually have some changes to our texts that have human written rewrites. And then we had complete gibberish, just two random sentences connected together. There's clearly no semantic similarity whatsoever. And what we managed to show is that, first of all the available metrics, they are heavily correlated. And second of all, some of them are actually not applicable to semantic similarity measurement because they actually show that complete gibberish pairs of sentences do actually have some semantic similarity, which is not what you want to have at all. And then there is a particular metric which is called word mover distance, which seems to be the most promising one, but it's not a silver bullet. So we have metrics for semantic similarity available, but it's open and it's not clear if they work and to which extent do they work and where do they fail us. And this is something that needs further and deeper study and is an open question that maybe you or one of you could address. So let me draw the conclusions of the whole story that I covered so far here. I will not go further, but we also have some ideas on how you work with narrative and so on. And if you're particularly interested in this kind of research of narrative generation, please drop me a line. So we started with a very, very simple premise. Can we learn style end-to-end? And the answer was yes, we can. Then it turns out that not only can we learn style end-to-end, to some extent we can decompose stylistic and semantic information in text, but it is much harder than, for example, for images. And partly it's because we don't have good measures of semantic similarity, and partly it's because the decomposition quality affects the resulting performance, and we know how to assess the resulting performance, but we don't know how to assess the decomposition quality in the latent space. And this is another very interesting mathematical and geometric problem that we're currently working on. And so far, we do have to have human rewrites as a baseline in order to test this kind of systems, but there is certain hope that once we get better metrics of semantic similarity and better geometric interpretation of our semantic spaces, we might have a breakthrough here and be able to actually manipulate text in a far more minute and precise way. With this, I rest my case and I'm open to the questions because we've got 5 minutes left.
Ivan, thank you very much for your presentation.
Sure.
It was very informative, and as a person quite far from machine learning, I still was able to understand what you were talking about. And actually, I was very involved in this. So thank you again. We have a couple.
Thanks. You're being
We have a couple of questions here. The first one: at what level does style exist? At the level of sounds, words, sentences, or phrases?
That's a very good question. Who asked it?
So yeah, could you just answer?
All right, so we don't know. The short answer is that we don't know. But there are way more things that we don't know. We don't even know what is the right level of granularity for the representation of textual information. Because if we talk about European languages, then letter is definitely too small, right? What is a letter, come to think of it? It's not a sound, because it can sound differently in different contexts. It doesn't have any semantics whatsoever, but then you can also sometimes have a letter that does have semantics. For example, you can have the word something like, well, like you can have something like well, okay, two letters can definitely have meaning, right? For example, you can have something like important, and then you can have UN, and then it's unimportant. So just two letters definitely clearly has meaning. You're actually going to have examples with one letter, but I'm a bit rushed, so I cannot come up with it. But the point is that there is some semantic component to it, but the level of granularity on which you have to look at a particular word representation even is not clear for us. And this is why we try to find some mappings of semantic into some state space where we take the whole sentence or the whole piece of text and basically try to interpret geometrically what it is about and just decompose style out of it, because we don't know even what is the right level of textual representation. Now, when we talk about where style lives, it's clearly on the level of sounds when we talk about poetry. And there is another paper where we show that sound information contributes a lot to the quality of the poetry generation model. So it is on the level of sounds, that's for sure. I personally think that sound is actually fundamentally underestimated in the natural language processing research, and there are a lot of things to be done there. Then it's clear on the lexical level, because the choice of words is different and the distributions of words are different for different authors. However, when we look at the average distribution, so when we look at the word frequencies, what the model does when it learns the vocabulary of the author, it mimics the word frequencies, but it's not only the word frequencies per se. So we try to compare as a baseline the model that was basically sampling the words of the same author frequencies out of this random distribution, trying to resemble the author just lexically. But apparently it's not only which words we use, but also how the words are connected. And this interdependencies model also apparently contribute to the stylistic impression that the text makes on us. But this is these things are far more subtle, and it's much harder to measure them. But on all three levels, there's clearly some aspects of semantic information encoded. Sorry, stylistic information encoded. Yeah. The next question.
Thank you. The next question is also connected to the previous one. It is the following: does the proposed model take this into account? So
yeah, sure. So our model actually, if you look in the paper, there's several of them, and we've described the embeddings of the model. So we took into consideration the phonemes. So we took the transcription of the word. And for the words for which we didn't have the transcription out of vocabulary, we used some heuristical transliteration, which was suboptimal. But once again, for majority of the words, you do have phonemes. And we even show that through the ablation study, that if you throw away this phonetic information, the quality actually reduces. So we did have phonetic information. We had a letter by letter representation as well. Then we had information on the author and on the particular poem that it wrote. So they were also part of the embedding. We had a composed, very large embedding where different aspects of text were concatenated together. And we did a ablation study that showed to which extent every part of this embedding contributed to the final result. And it turns out that each of them makes a difference. So yeah, we experimented with it, and we tried to the best of our capabilities, show rigorously that all these levels of information are important.
Thank you. Thank you very much. So we're done with questions, I guess, and I thank you once again for your presentation and for answering the questions, and wish you a very good day. And for all of our listeners, I remind that we are having more lectures to come. So please monitor them on our official website, and see you soon. Goodbye.
Thanks a lot for joining. Goodbye, everybody. Have a good school.